atomic structure and the numbers on the periodic table. There once was a place called Matterville. Everything in Matterville took up space and had mass. Matterville was balanced. 3 family members lived in Matterville. The first one's name was Patty Proton. Patty Proton has a positive disposition, always happy and on the positive side. The second member that lived in Matterville was Nelda, and she was neutral. Neutral, Nelda, neutron lived in Matterville. Then there was an angry little guy by the name of Elliot Electron. He had a negative disposition, never in a positive mood. In the center of Matterville was a Nucleus arcade, a place where the kids like to hang out and play games. The Nucleus arcade was a place where Nelda and her sister, Positive Patty, hung out. But once Nelda and Positive Patty hung out together in the Nucleus, it was too crowded for anyone else. So dense and so crowded, Elliot Electron could not come in. Instead, Elliot Electron angrily zoomed about around the Nucleus arcade, looking in, jealous of what he was missing on the inside. Never able to get in the Nucleus arcade, he zoomed about around his motorcycle super fast, but never coming close enough to come into the Nucleus arcade. What I'm really describing here is the structure of an atom. As you can see in the picture here, atoms have a dense nucleus with 2 types of particles, protons and neutrons. Then surrounding the nucleus, I have fast-moving, very much smaller particles called electrons. So I have positive protons and they're in the center. I've got neutral neutrons with no charge, not positive or negative. And I've got electrons, which are negative, and they do not belong in the nucleus, but rather zooming around in a cloud-like form. Negative. So I have a positive, a negative, and a neutral particle in all atoms. Not all atoms come with the same shape and size. The heavier the element, the more protons and neutrons and electrons it will have. So how can I tell what an element's atom looks like? All the information we're going to need is located on the periodic table. Take, for example, lithium. Lithium's symbol is capital L, little I. It has a number up here of 3 and a number down here of 7. It is said the top number is lithium's atomic number. Atomic number. The bottom is lithium's mass. Atomic mass. So how much one atom weighs. So now that we know what the atomic structure is, the 3 family members or the 3 particles inside an atom, let's think about the periodic table and what it tells us about the atom. So for example, in lithium, I've got a number 3 on top and then a 7 on the bottom. We discussed that the 3 was the atomic number and 7 was the atomic mass. What that really means is that 3, the top number, indicates that there's 3 protons and 3 electrons. They must be equal. Then if I take 7 minus 3, mass minus atomic number, I can get my neutrons, 4 neutrons. So as you know, the protons and neutrons like to hang out in the nucleus, so 3p and 4n in the nucleus. An Elliott electron must zoom around on the orbits on the outside. So I put 2 electrons on the first street and 1 on the last street. Now why would I do that? Why not put all 3 on the first street or the first energy level? And that is because the first energy level of any atom can only hold 2 electrons. The second energy level can hold up to 8, but it doesn't have to hold 8. And the third energy level can hold up to 18, but it doesn't have to hold 18. So in the case of lithium, because the atomic number is a 3, I have 3 electrons, 2 on the first street and 1 left over for the second street. This is a flat Bohr model, B-O-H-R, Bohr model, of what lithium looks like, its atom. Remember, lithium is an element, and this is its shape, or its atomic shape. Let's do another example. What if I draw the square for hydrogen? Hydrogen being the most abundant element on Earth. Its atomic number is 1, and its mass is 1. Therefore, I have 1 proton, and I have 1 electron. Again, they must be equal to be stable. And I have 0 neutrons because 1 minus 1, the mass minus the atomic number, is 0. So 0 neutrons. So the only particle inside the nucleus arcade is 1 proton. And on the first street, I only put 1 electron. This is the simplest atom there is in the universe and the lightest and most abundant. In our third example, we're going to discuss an atom that is abundant in many of our white substances and in our bodies and all living things, and that's carbon, element number 6. Remember, the top number tells me a number of protons and electrons. So 6 protons, 6 electrons. Then for neutrons, I take 12 minus 6, or 6 neutrons, bottom number minus top number. Neutrons is the only one in which I have to calculate. Now for my nucleus arcade, or my arcade nucleus, in the center I've got the protons and neutrons again, so I just simply write them in. Oops, not electrons. Electrons don't belong in the nucleus. 6 protons and 6 neutrons. Then for my first orbit, my first electrical orbit, I can only fit 2 electrons, so 2 of the 6, and I must draw a second energy level for the other 4. Remember, the second energy level can hold up to 8. I just need 4, total of 6. In our next example, we'll go to the far right of our periodic table in the top right-hand corner for our first noble gas. His name is helium. Its atomic name is helium, or He. Its atomic number is 2, and its mass is 4. What does the top number mean? That's right. Top number is protons and electrons. What is the bottom number minus the top number? Neutrons. And so it's 2, 2, and 2 here. Making my model, I'll start, of course, with my nucleus with protons and neutrons. And then I will only need 1 orbit because I only have 2 electrons. And that is the very simple, very stable helium. In this last example, I want to talk about another element in that far right-hand column, and it is neon. Remember, I always start with the symbol, and then the atomic number, and then the atomic mass. Okay, I'm going to go straight to drawing it. Since I know the conventions, the top number tells me number of protons. The bottom number minus the top number tells me the number of neutrons, so 20 minus 10 is 10 neutrons. On the first energy level, I can only hold 2 electrons, and I need 10, so I'm going to draw 2 electrons on the first level. Notice this time I just put their negative symbol. It is fine to do dots for electrons, or negative symbols, or E's for electrons. In the second level then, I need to fill up with the remaining 8. 3, 4, 5, 6, 7, 8. Remember, the levels are 2 on the first street, 8, and 18. Those are the limits. So in this case, the second level is completely full. It has 8, and that's all it can hold. When a level is completely full, it belongs to the noble gas family, which is the far right-hand column. We had helium before, which was also a noble gas. And what it means is that this last level being full, it doesn't like to bond with other elements. And usually you'll find noble gases all alone, not with any other element. If you'll remember, sugar, for example, was carbon bonded with hydrogens, bonded with oxygens. And in this case, it is all alone because its outer level is full. It has no more room to bond with anything else. Okay, to recap, we have been talking about the atomic model and the role the periodic table plays in determining what the model looks like. The specific model we've been looking at is called the Bohr model because Mr. Bohr created it. I always start with the box on the periodic table. First, determining the symbol. This is lithium, its atomic number, and its atomic mass. From there, I begin by drawing a nucleus. The nucleus holds protons and neutrons, and in lithium's case, the top number indicates protons, so 3. The bottom number minus the top number determines neutrons, and so 4. The first street can hold up to 2 electrons, and lithium has 3, it's the top number. So therefore I have to spill over into a second street. And the atomic model for lithium looks like this. It's Bohr model. And all the information I needed was on the periodic table.